So let's take a look at the limits. And what I have here is your test. And then I'll toggle between the two for the working of each limit. So the first one is the limit as x approaches 0 of the quantity 1 over x minus 1 plus 1 over x. Now, you can see by putting x in that we are not defined at x, and that's the issue with this limit. So what we're going to do is we're going to take a look at this function inside, and we're going to change the way it looks so that we can evaluate the limit. So I'm going to look and do 1 over x minus 1 divided, and then add x minus 1 over x minus 1 to combine the two terms on the top. After simplification, that gives me x over x minus 1 all divided by x. Now to finish simplifying this, I'm going to say this is x over x minus 1, and then to divide by x, I multiply by its reciprocal. And the reciprocal would be 1 over x. You'll notice now that we can simplify, and what we end up with is 1 divided by x minus 1. So all I did is I worked with the fraction and simplified it, manipulated it, if you will. And this is going to be equal then to x as x approaches 0. It's going to be equal to the limit as x approaches 0 of 1 divided by x minus 1. And when you can then put 0 into that function, you'll see that that would be equal to a negative 1. Okay, so this we had to simplify the function inside of the limit. Let's take a look at the next question on the test. So here we have the limit as x approaches 1 of the square root of x plus 3, get the rest of it, minus 2 over 1 minus x. Okay. Now here again, we are not defined at 1. So we can't simply put the 1 into this function. So we're going to have to manipulate the function. Now, if I multiply the top and bottom by 1 plus x, which would give us a 1 minus x squared in the denominator, and then additional factor of 1 minus x squared in the numerator, it wouldn't help us. Because at 1 minus x squared, which is what is in the denominator, it would still be undefined. So what does catch my eye is the square root of x plus 3 minus 2. And I'm going to multiply the top and bottom by the conjugate of the numerator. And this is what it would look like in the simplification. All right, so we have the square root of x plus t minus 2 over 1 minus x. And then I'm going to multiply the top and bottom by the square root of x plus 2 over, there should be a 3, the square root of x plus 3 plus 2. All right, so notice I'm multiplying the top and bottom by the same value. So I'm not changing the value of the function, I'm just changing how it's going to look. And so when I do this, I have a sum and difference in the numerator, and it's going to be a difference of 2 squares. And I'm going to leave it in the numerator. I'm not going to multiply anything out. This is actually looking pretty good. I'll show you why. After a little simplification, you'll see that this x plus 3 minus 4 is equal to x minus 1. Now, since I have an x minus 1 in the numerator and a 1 minus x in the denominator, they are opposites. And when you cancel opposites, you end up with a negative 1. So now what I have is a negative 1 divided by the square root of x plus 3 plus 2. Now if you look at the function and remember that we're looking at the limit as x approaches 1, we can put a 1 into this function. And when we do that, I'm just going to replace the function we have with a comparable function. Same values, same graph, it just looks different. And when I put 1 in, I end up with a negative 1 over 4. Negative 1/4 will be the answer to this function, or limit. All right, let's move on. This was, I should label them, this was number 2. Let's move on to number 3. Let's see, what did we have for number 3? Oh, the limit as x approaches infinity of x on the tangent of 1 over x. As we go to infinity, okay, as x goes to infinity of x times the tangent of 1 over x. All right. Well, right now, what we have going on is if we substituted this, right, the limit of x as x goes to infinity, that goes to infinity. And the limit as tangent of 1 over x, okay, well, as 1 over x it goes to 0, so we have tangent of 0. So things don't really work out because we have infinity times 0. Okay. Now later on, you're going to have a property called L'Hopital's rule, which will make everything easier. But for this case, we're going to change how things look a little bit. And I'm going to actually do a substitution. I don't know if you talked about substitution, but I think it's the easiest way to go. So what this will look like is I'm going to let t be that inside part, because that's kind of one of the problems I'm having here. T is equal to 1 over x. And what that then means would be x is equal to 1 over t. And as if t is equal to 1 over x, as x approaches infinity, if we look at everything that happens here, t approaches 0. So we're going to change how our function looks using substitution. And we're going to say that this is equal to the limit as t approaches 0 of 1 over t. That's what we replace x with, is this 1 over t tangent of t. All right, now I'm going to have a little more, I have a little more stuff to say on this one because it's these limits are equal, but I'm going to rewrite it. I'm going to need a little more room. So I'm going to take this, sorry, I'm going to start again there. So the limit as t approaches 0 of 1 over t, and then tangent of t. Now, tangent of t, I can't work with as well, but I'm going to write this then as the sine of t over the cosine of t. I like that. Now, the reason I like that is because there is this property that says the limit as x approaches 0 of sine x over x is equal to 1. All right, so I'm going to use that property here. So this is a property. It's in my little thought bubble. I want to make sure that we know that's not the answer here. But I'm going to write this as the limit as t approaches 0 of sine of t over t times 1 over cosine of t. All right, now when we look at this, if I put 0 in as t goes to 0, sine of t over t, this is going to go to 1. And as limit as t approaches 0, well, the cosine of 0 is 1. So this is also going to go to 1. So in the end, our answer is equal to 1. That would be my final answer. So I'm going to highlight my answer here. Let's take a look at number 4. Let's grab it from the upper page. Number 4. So we have the limit as x approaches 0 of e to the x over x cubed. All right, so if we look at this as x goes to 0, e to the x goes to 1. And as x approaches, as x goes to 0, x cubed goes to these very, 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 very tiny little numbers. Very, very, very tiny. So whenever you divide 1 by numbers that increasingly go smaller and smaller and smaller, this whole piece right here, this whole piece will approach infinity. So in the end, we would say that this limit does not exist because it goes to infinity. So it has no limit. Let's take a look at number 5. And I'm going to grab this one. Oh, and this looks fun. Okay, so the limit as x approaches 0 of the sine of 5x divided by 3x. All right, now we have this property that I mentioned before. I'm just going to write it in some shaded area here. And that is the limit as x approaches 0 of the sine of x divided by x is equal to 1. All right, so what we want to do is we want to make that the argument that's inside the x, or inside the sine function, we want to get the denominator to equal that. And that's not too hard. So, because if we do that, we know that that limit is equal to 1. And so what I'm going to do to force that is a little trick. Is I'm going to multiply the bottom by 5/3, and I'm going to multiply the top by 5/3. Now notice the 3's will cancel. And this will now give me the limit as x approaches 0 of 5/3 times the sine of 5x, all divided by 5x. All right, now this piece here that I'm highlighting, that's going to go as x goes to 0, that goes to 1. So this will end up being, our limit ends up being 5/3.